Hey, what's going on, guys? It's Mr. Sanchez coming at you with another lesson for pre-calculus. Today we're doing section 4.3 complex zeros. Now we've already gone over this in class, so this is notes. Is more for those of you who had a little trouble focusing in class. And I actually wrote down the conjugate pair theorem. So our learning targets are use the conjugate pair theorem and find polynomial functions with specified zeros. This is technically part one. There's going to be a part two later on in this week. And basically all of this theorem says is we'll just go down here, and this is a conjugate pair theorem, and it says let f of x be a polynomial function whose coefficients are real numbers. If r plus abi, if r is equal to a plus bi, so this is the way we typically see a complex number, so an imaginary number, is zero of the complex conjugate of f. So if this is a zero of f, then I don't know why this is gonna have n, but then the complex conjugate r minus abi should also be on the a zero. So basically what we're saying is what we said in class yesterday or today, which depending when you're watching the video, finding the remaining zero. So I'll show you over here. So right here you're gonna notice we have a polynomial of degree 4, and it also says that zeros are I, 2, and -2. So if I is a 0, then the remaining 0 that you need to find is -I, and that's your conjugate pair, right? It's like having a pair of shoes. If you buy the left shoe, you get the right shoe. So if you get positive I, then you also have -I as the 0. And that's as easy as it gets. It doesn't get any more complicated than that. All right. And here's another example. So now we have a polynomial of degree 5. We have the 0, 1, 2i, and I. Because of the conjugate pair theorem, we can find the remaining two zeros. So because we have positive 2i, we should also have negative 2i. And since we have positive I, we should also have negative I. All right. And those are the two remaining zeros. And if you count them, that's 1, 2, 3, 4, 5. 5 zeros for a polynomial of degree 5. All right. That's what the conjugate pair theorem says. And you notice how it says you'll notice here how it says r equals a plus bi. So that all that means is if they gave us 2 plus I as a 0, that means you're also gonna have 2 minus I as a 0. That's all that conjugate pair theorem says. And it's the same thing here. It's the same thing here. The only thing is that this a would be 0. So that's why we don't it works here also. All right. So that's the first type of problems you're going to encounter. We already did some of these in class. The other type of problems you're going to go ahead and encounter are when we give you the zeros and you have to find the polynomial function. Okay, so form a polynomial function f of x with real coefficients having given degree and 0. So all right, so let's start here. We have a degree 4. So we know our answer should have x to the 4th minute, and we have zeros 3 plus 2i, 4 multiplicity 2, right? So whenever we're given zeros, remember you always write it in the form of x minus the 0. So right here will be x minus 4, and you're gonna square it because it has multiplicity 2. But remember, if we have 3 plus 2i, then we should also have 3 minus 2i. So the other way you're gonna write the zeros is gonna be x minus that. So, and I'll put that in parentheses. 3 plus 2i times x minus, and then we also have 3 minus 2i as a 0. If we were to distribute the negative, you should have x minus 3 minus 2i as a 0, and then x minus 3 plus 2i as a 0. All right, and then we know x minus 4 is going to be x squared minus 8x plus 4 because that's a perfect square. All right. And so to find out what this equals when we multiply, we got to do the box method. All right, so I'm gonna have x minus 3 minus 2i, x minus 3 plus 2i. So all these problems, the conjugate pairs make sure, when we use the conjugate pairs, they're going to make sure that we get rid of the I as part of our answer, okay? So if you end up with I as part of your polynomial, you probably messed up somewhere. and you're gonna want to double check your work. So first we start off with x times x. That's gonna give us x squared, x times -3, which is -3x, x plus times 2i, which is 2ix, and then -3x, +9, and then -6i, -2ix, plus 6i, because it's negative times negative, and then -4i squared. Okay. So that's what happens when we follow this out. All right. So x squared is going to be the first term, right? -3x minus 3x is -6x. -2i and +2i cancel each other out. 6i and -6i cancel each other out. -4i squared becomes -4 times, and then remember, I squared is -1. So -4 times 1 is -1 is +4. So 9 plus 4, which will give us 13. Right, so that's our, so far we have this times x squared minus 8x plus 4. Right, and then we're just gonna do the multiplication one more time. So we're gonna multiply those two together, and then that's gonna give us our final answer. Okay, so we gotta do our box here and here. Then we're gonna have x squared minus 8x plus 4. I'm gonna have x squared minus 6x plus 13. And we're just gonna do some multiplication here. X squared times x squared is x to the 4th minus 8x cubed plus 4x squared minus 6x cubed plus 48x squared. And then -6 times 4 is -24x, 13x squared. I actually don't know what 13 times -8 is, so now you just type in the calculator. 8 times 13 is -104x, and then 13 times 4 is 52. Now, I actually might have to use a calculator for this. I'm not, So we have x to the 4th, right? And then -6 minus 8 is -14x cubed. 13 plus 4 is 17. But let's make our lives easier. We'll do 4 plus 48. That's 52 plus 13 is 63x squared, I believe. 65. Nope. Let's do this in the calculator. I'm not gonna risk it. I don't want anyone telling me I did this wrong. So 4 plus 48 plus 13 is 65x squared. All right, so I use the calculator. The -104 minus 28. 104 plus 24. So it's -128x plus 52. And that here is our polynomial. All right, we're gonna go ahead and try this one again. This next one. So once again, we have that's our, you see, another polynomial, degree 4 with 0 is 3 with multiplicity 2 and -i. So we have -i, we should also have +i. Okay, and so we have x minus 3 multiplicity of 2, and then x minus I, x plus I. Okay. Here's a cool fact. You should remember this. Whenever you have this is technically a difference of squares, but you should know that this becomes x squared plus 1. And then we know that x minus 3 squared is going to be x squared minus 6x plus 9. Okay. And then we're just going to distribute. I'm going to distribute the good old fashioned way. I'm going to have x to the 4th plus x squared, right? And then we're going to have minus 6x squared cubed, 6x cubed minus 6x plus 9x squared plus 9. All right, so that gives me x to the power of 4 minus 6x cubed. And you have x squared plus 9x, so plus 10x squared. And then -6, so minus 6x plus 9. And that's our polynomial. And that's basically the first half of this lesson. The next lesson, we're gonna go backwards. We're gonna go from here to here. Well, we'll do that in part 2 of this section. All right, guys. Thank you for watching the video. Hopefully this helps out. If you have more questions, ask me in class. I'm not gonna get mad if you don't get anything. All right, bye. Bye.